Hi everyone, welcome to Monitor Max channel where we discuss all things machine condition monitoring. Today we're diving into the world of centrifugal pumps. These workhorses are the backbone of countless industries. They keep our water flowing, our oil pumping, and our factories humming. Centrifugal pumps are everywhere, from your car's engine to massive industrial plants. Ever wonder how they move liquids with such power and efficiency? Well, buckle up because we're about to break it down. These pumps use a fascinating combination of physics and engineering. By the end of this, you'll be able to impress your friends with your newfound pump knowledge. Let's get started. Alright, let's pop the hood and see what's inside a centrifugal pump. Don't worry, we won't get too technical. At its heart, a centrifugal pump has a rotating component called an impeller. Think of it like a fan blade inside a housing. This impeller sits on a shaft connected to a motor. The housing has an inlet where the liquid enters, and an outlet where the pressurized liquid exits. There's also a bunch of seals and bearings that keep everything running smoothly. We'll delve into these parts in more detail later. For now, just remember impeller, housing, inlet, outlet, those are the key players. Now, for the fun part, how do these things actually work? Centrifugal pumps are fascinating pieces of engineering that play a crucial role in many industries. From water treatment plants to oil refineries. They are designed to move liquid efficiently and effectively. But the magic lies in their simplicity and the principles of physics they exploit. It all comes down to centrifugal force, hence the name. Centrifugal force is the apparent force that draws a rotating body away from the center of rotation caused by the inertia of the body. This force is harnessed in the pump to move liquid. Imagine swinging a bucket of water in a circle. The water gets pushed outwards, right? This is because the water inside the bucket wants to move in a straight line due to inertia, but the bucket's walls keep it moving in a circular path, creating an outward force. That's centrifugal force in action. This same principle is applied in centrifugal pumps to move liquid from one place to another. In a centrifugal pump, the spinning impeller does the same thing. The impeller is a rotating component equipped with vanes or blades that direct the liquid's flow. Liquid enters the pump at the center of the impeller, also known as the eye of the impeller. This is where the magic begins. As the impeller spins, it flings the liquid outwards due to centrifugal force. The vanes of the impeller impart kinetic energy to the liquid, increasing its velocity. This creates a low pressure area at the center and a high pressure area at the outlet. The low pressure at the center allows more liquid to flow into the pump, while the high pressure at the outlet pushes the liquid out. The high-pressure liquid then gets pushed out of the pump and into the discharge pipe. This is how the pump moves liquid from one place to another, overcoming resistance and elevation changes. It's like a continuous cycle of sucking in liquid and throwing it out with more force. Pretty neat, huh? This cycle repeats as long as the pump is running, making centrifugal pumps incredibly efficient and reliable for a wide range of applications. So, why are centrifugal pumps so popular? Well, they have some pretty awesome characteristics. First off, they're relatively simple and robust. Fewer moving parts mean less can go wrong. They are also very efficient at moving large volumes of liquid quickly. Plus, they can handle a variety of fluids, from water to chemicals to slurries. This versatility makes them ideal for countless applications. They're used in water treatment plants, irrigation systems, oil and gas industries, power generation, and even in your home appliances. If you need to move liquid, chances are a centrifugal pump is up to the task. Section 5, Classification of Pumps. Now, not all pumps are created equal. Just like there are different types of cars for different needs, there are different types of pumps for different jobs. Pumps can be classified based on various factors, such as their size, the type of liquid they handle, and how they generate pressure. One common way to classify them is by their displacement method. Positive displacement pumps and non-positive displacement pumps. Centrifugal pumps fall under the category of non-positive displacement pumps. This means they don't deliver a fixed volume of liquid per rotation. Instead, the flow rate depends on factors like the pump's speed and the pressure at the inlet and outlet. Section 6. Major components, stationary and rotating. Let's revisit the anatomy of a centrifugal pump, this time digging a little deeper into its main components. We can divide these components into two groups, stationary and rotating. The stationary parts include the pump casing, which houses the impeller and guides the flow of liquid. Then there's the suction nozzle, where the liquid enters the pump, and the discharge nozzle where the pressurized liquid exits. And let's not forget about the bearings and seals which keep everything running smoothly and prevent leaks. On the rotating side, we have the impeller, the star of the show. The impeller is mounted on a shaft which is connected to the motor that provides the rotational energy. Section 7. Understanding impellers. The impeller is the heart of a centrifugal pump, driving its core function. It's what converts rotational energy into kinetic energy, giving the liquid its necessary boost. Impellers come in various shapes and sizes, each designed for specific applications and unique flow characteristics. Some common impeller types include open impellers, semi-open impellers, and closed impellers. Open impellers are like free-spinning blades, ideal for certain conditions, while closed impellers have shrouds on both sides to better guide the liquid flow. The choice of impeller depends on factors like the viscosity of the liquid, the required flow rate, and the efficiency needed for the task. Section 8. Net Positive Suction Head, or NPSH. Now for a slightly more technical but crucial concept, Net Positive Suction Head, or NPSH. This term might sound complex, but understanding it is essential for anyone working with pumps and fluid systems. NPSH is a key factor in ensuring that your pump operates efficiently and reliably. In simple terms, NPSH is the difference between the pressure at the suction inlet and the vapor pressure of the liquid. Why is this important? Well, the pressure at the suction inlet must be high enough to keep the liquid from vaporizing. If the pressure drops too low, the liquid can turn into vapor, leading to a host of problems. Well, if the NPSH is too low, the liquid can start to vaporize inside the pump. This is bad news. Vaporization inside the pump can lead to cavitation, a phenomenon where vapor bubbles form and then collapse violently. This can cause significant damage to the pump components. Vapor bubbles can form and then collapse violently when they reach a high-pressure zone. This collapse generates shock waves that can erode the pump's internal surfaces, leading to pitting, cracks, and even complete failure of the pump over time. This phenomenon, known as cavitation, can damage the pump and significantly reduce its performance. Cavitation not only shortens the lifespan of the pump, but also decreases its efficiency, leading to higher operational costs and potential downtime for repairs. To avoid cavitation, it's crucial to ensure that the NPSH available, provided by the system, is greater than the NPSH required, specified by the pump manufacturer. The NPSH available is determined by the system's design and operating conditions, while the NPSH required is a characteristic of the pump itself. This involves factors like the liquid level in the suction tank, the pipe size, and the flow rate. Ensuring that these factors are optimized can help maintain a sufficient NPSH, preventing cavitation and ensuring the pump operates smoothly. Regular monitoring and maintenance are also key to keeping the system in check. Section 9. Cavitation, a pump's nemesis. Cavitation is the archenemy of centrifugal pumps. It's like the pump equivalent of an engine knocking, a sure sign of trouble. As mentioned earlier, cavitation occurs when vapor bubbles form in the liquid due to low pressure and then collapse violently in high-pressure zones. These collapsing bubbles create shock waves that can erode the impeller and other pump components over time. This can lead to reduced efficiency, increased noise and vibration, and even catastrophic pump failure. To combat cavitation, engineers carefully design pump systems to ensure adequate NPSH. This might involve raising the liquid level in the suction tank, using larger diameter pipes, or reducing the flow rate. Section 10. Conclusion. The power of centrifugal pumps. That's a wrap on our whirlwind tour of centrifugal pumps. We've explored the fascinating world of these essential machines, delving into their history, design, and the science that makes them so effective. We've covered a lot of ground from the basic components and working principles, such as the impeller, volute, and casing, to the physics of fluid dynamics that allow these pumps to move liquids efficiently. We've also delved into more advanced concepts like NPSH, or net positive suction head, which is crucial for preventing cavitation, a phenomenon that can cause significant damage to pumps if not properly managed. These incredible machines play a vital role in countless industries and applications. From water treatment plants ensuring clean water supply, to oil refineries processing crude oil, centrifugal pumps are indispensable. They're reliable, efficient, and versatile, making them the go-to choice for moving liquids of all sorts. Whether it's for heating and cooling systems, chemical processing, or even in everyday appliances, Their applications are vast and varied. By understanding the basics of how they work and how to keep them running smoothly, we can extend their lifespan and ensure they operate at peak efficiency. Regular maintenance, such as checking for wear and tear, lubricating moving parts, and monitoring performance is key. We can ensure that these workhorses keep our world flowing. The continuous movement of liquids is critical for many processes, and centrifugal pumps are at the heart of this movement, ensuring everything runs seamlessly. So next time you see a pump, take a moment to appreciate the ingenious engineering behind it. These devices are more than just mechanical components. They are marvels of engineering that embody the principles of physics and fluid dynamics. It's a testament to human ingenuity and our ability to harness the power of physics to solve real-world problems. From ancient water wheels to modern centrifugal pumps, our journey with fluid movement has been long and innovative. Keep on pumping. If you found this useful, please subscribe, like, comment, and share with friends and colleagues.